Introducing XLTA, the next generation in wound care. This hydrocapillary flow demonstration shows how XLTA sets a new standard as a super-absorbent, non-adherent Exudate management system. The clear bottle contains water representing Exudate, fluid naturally produced by a wound bed. The other contains food dye, simulating bacteria and inflammatory byproducts in wounds. These fluids allow us to visualize how XLTA functions in a real-world wound environment. Exudate management through hypocapillary flow powered by XLTA. The clear fluid is poured to simulate a moist wound bed. As we introduce the dyed fluid, we simulate the presence of bioburden, bacteria, cytokines, and enzymes. A pre-cut piece of XLTA is now applied to the fluid. Instantly, the dressing begins to sequester, disperse, and retain the exudate. XLTA's hydrocapillary mechanism activates, drawing moisture rapidly across the entire dressing both horizontally and vertically. The dressing locks the exudate in place with no backward leakage. When dry fibers are introduced, such as a fresh layer of XLTA, they make immediate contact with the moisture, pulling fluid from the original layer into the next. This continuous fluid transfer is a key advantage of XLTA's multi-layered design. Moisture control using hydrocapillary fluid wicking technology powered by XLTA. As the fluid contacts the dressing, XLTA's hydrocapillary system activates immediately, drawing the exudate vertically into the internal matrix. The bacteria-simulating dye is visibly carried along with it, showing how XLTA absorbs and distributes fluid without delay. XLTA locks in the fluid and sequesters bacteria within its fiber. This prevents backflow and creates a moist, stable wound environment conducive to healing without maceration. Watch as a second dry XLTA layer is introduced. Fluid and dye are horizontally transferred into adjacent dressing through hydrocapillary action. This demonstrates XLTA's omnidirectional dispersion, enabling coverage over complex wound geometries. Function is not depleted after the first use as new exudate is produced and dry fiber remains. Absorption continues. Even minimal contact, like a single corner, is enough to initiate transfer. No need for chemicals or active pressure. This is the new hydrocapillary standard in wound care, reducing bacterial load through natural fiber powered by XLTA technology. XLTA's ability to wick fluid to circumvent obstructions. In this demonstration, we've removed the center of the dressing to simulate an obstruction, whether from a cavity, a tunnelling wound, or a gap in coverage. As we introduce fluid to the wound bed, you'll notice how XLTA's hydrocapillary mechanism redirects the exudate, pulling it around the missing section instead of pulling at the site of disruption. This response is driven by XLTA's omnidirectional dispersion, but around voids and anatomical irregularities where traditional dressings fail, leaving moisture trapped or stagnant near hard-to-dress areas. XLTA responds dynamically. The cutout section creates a break in continuity, but the surrounding fibers remain active. You can see the fluid traveling around the obstruction, continuing its path through the interconnected dressing layers. This is a key differentiator. XLTA doesn't require direct contact with every wound surface to remain effective. Instead, its proprietary blend of natural fibers coordinates fluid transfers across all connected areas. Even with disrupted geometry, the dressing retains fluid, sequesters bacteria, and manages moisture, safeguarding the wound environment. This performance makes XLTA ideal for challenging wounds such as undermining, tunneling, or partial exposure sites where coverage is incomplete or inconsistent. Bioburden relief by assisting autolytic debridement in optimal wound bed preparation. XLTA's lift, lock, and hold rapid fluid absorption and retention against gravity. Dye is directly applied to the non-adherent layer of the base dressing, demonstrating that XLTA absorbs effectively from either side. A single pre-cut piece of XLTA is then placed upright, standing vertically on top of the flat dressing. As additional fluid is added to the lower layer, XLTA's hydrocapillary action activates, tearing the exudate and dye upward into the vertical piece. This clearly demonstrates XLTA's ability to wick fluid vertically against gravity, ensuring continuous absorption even in layered or irregular applications. Whether flat or standing, the dressing remains fully functional, maintaining fluid control and bacterial sequestration omnidirectionally through every layer. Omnidirectional dispersion of fluid using hydrocapillary fibers powered by XLTA technology. Here, fluid is applied directly to the non-adherent surface found on both sides of the dressing. No side is the wrong side when applying Xulta. The fluid is rapidly absorbed, unobstructed by the non-stick interface. Exudate and bacteria are evenly dispersed omnidirectionally through the proprietary Xulta fibers. Xulta's signature stacking protocol for extended wear and increased moisture retention capacity. This demonstration shows how Xulta absorbs fluid not only horizontally, but also vertically against gravity. We begin by applying fluid to the center of the dressing. The hydrocapillary action pulls the fluid evenly in all directions, dispersing it across the entire dressing in others that are in contact. If Exudate exceeds expectations, pooling can lead to maceration or overgranulation. That's why we always recommend using at least 2 layers when possible. In this case, the top layer draws fluid upward from the saturated layer below, expanding capacity while maintaining a balanced moisture environment. This also enables Xulta to transfer bacteria upward, reducing bioburden across multiple layers. As Exudate is secreted, the fluid moves through to the upper dressings without pressure or compression. This capability is ideal for hard-to-dress wounds such as venous leg ulcers, where fluid must be wicked away from delicate or eroded wound beds. Xulta's hydrocapillary flow ensures consistent fluid movement, omnidirectional dispersion, and continuous bacteria sequestration, all without chemicals or medication. The result? Effective exudate management and moisture regulation. Xulta can be used to fill cavities and tunneling wounds with creative customization. In deep or irregular wounds, Xulta is cut to fit and placed directly into the wound where it draws debris and bacteria out from within the cavity using hydrocapillary flow and electrostatic charge. As fluid is introduced, it is absorbed by the base and pulled up through the dressing. Bacteria are attracted to Xulta's positively charged fibers and locked into the matrix. Xulta continuously clears the wound cavity, reducing bioburden and restoring balance, supporting a cleaner wound bed through natural healing processes. Xulta's unique composition of natural fibers also allows the material to hold a positive electrostatic charge, attracting bacteria which are mostly negatively charged. Xulta addresses deep wound cavities through its hydrocapillary action, electrostatic charge, and proteolytic enzyme balance by drawing negatively charged bacteria out from the deeper tissue to the surface of the wound bed. As exudate and bacteria are produced in the cavity, Xulta rapidly wicks it into the dressing. Bacteria, cytokines, and enzymes are electrostatically attracted from the deeper tissue and locked within the fiber matrix. This prevents further proliferation and contamination, restoring balance. The dye in this demonstration shows how fluid is pulled upward, diluting the bioburden through hydrocapillary action. Regular dressing changes every 1 to 3 days maintain this cleansing cycle and reduce bioburden, giving the wound bed a stable environment to heal.